Hello and welcome. In this video we're going to be looking at the solution for question 10 on the May-June 2023 CSEC Mathematics Paper 2. It is a vectors, matrices and transformation question, and the question begins by giving us two matrices, matrix A, which represents an anticlockwise rotation of 90 degrees about the origin O, which is 0, 0, and the matrix B, which represents a reflection in the lines y equal negative x. Now we are asked to determine the elements of the matrix C, which represents an anticlockwise rotation of 90 degrees followed by a reflection in the line y equal negative x. So to determine our answer, first we need to start with a point. So let's start with a point xy. Having gotten xy, first we need to rotate that point 90 degrees, and so we're going to use the rotation matrix to find what those coordinates would be, and the rotation matrix is 0, -1, 1, 0. After that is done, it will be followed by a reflection in the straight line y equal negative x, which means that we're going to use this matrix 0, -1, -1, 0. Now this is the matrix product BA, and sometimes students often make the mistake because it says we are supposed to find the rotation followed by the reflection. So often they write it in the order AB, rotation followed by reflection, and not in the opposite way. So having written it out this way, you can see that we are supposed to do BA instead of AB. Now C here, the matrix C that we need is equal to BA. So we need to find that product BA. Now let's multiply it out. 0, -1, -1, 0. We're going to multiply that by 0, -1, 1, 0. And of course, remember, when you're multiplying matrices, it's row by column. So 0 times 0 here is 0, and -1 times 1 here. So 0 times 0, -1 times 1, that's fine there. Then 0 times -1, and -1 times 0. That completes it for the first row. Row by column, then row by column. Then let's do that again for the second one. So it's -1 times 0 plus 0 times 1, and then -1 times -1 plus 0 times 0. Now of course this gives us here 0 times 0 is 0 plus -1, and here it gives us 0 plus 0. Here it gives us again 0 plus 0, and here it gives us -1 times -1 is +1 plus 0. So our answer then in terms of C would be equal to -1, 0, 0, 1. And that is our answer there. And next we move on to the other part of the question. So this is C. Move on to the other part of the question, which says describe geometrically the single transformation that is represented by C. So C is our matrix -1, 0, 0, 1. Let's write that down. -1, 0, 0, 0, 1. That is our matrix there. Let's write that down. This is matrix C. So you might be looking at the matrix and wondering, what does this represent? The best way to use it, the best way to know, is to take that matrix and multiply a point and a shape and see what it does with it. Or in this case we have a triangle, and here this is 1, 2, 3, this is 3, 1, this is 3, 4, 5, 6, 7, this is 7, 1, and here we have 3, 1, 2, 3, 4. So if we take this matrix and multiply a single point, for example 3, 4, and see what it does with it, then the matrix -1, 0, 0, 1 times 3, 4, what would it do to this point? And whatever it does to this point, we can replicate it for the others. So -1 times 3 gives us a -3, plus 0 times 4 gives us a 0, 0 times 3 gives us a 0, and 1 times 4 gives us 4. So the matrix takes that point and gives us -3, 4, which we can write as a coordinate, -3, 4. And what it says is that the point that we chose, 3, 4, 3, 4 becomes -3, 4. So we can write that in as -3, 4 would be here. And because this is what it does to that, then it's going to do to this point here. It's going to do the same thing to the others. So 3, 4 became -3, 4. 3, 1 would become -3, 1. And 7, 1 would become -7, 1. So 3, 4, 5, 6, 7. And this is what it's going to do to it. And how, now that we have a picture, what do we see? What does the matrix C do? What does it do? Geometrically, what does it mean? From what we can see here, we can see that it represents a reflection in the y-axis. I should write this. I didn't label my axis, so y-x. So this here, the image, would be a reflection in the y-axis. So this matrix here, C, is a reflection in the y-axis. Some persons actually memorize these, but in the event that you find these annoying to memorize, it's often better or easier on your mind if you should draw a shape, such as a triangle, and use that matrix on that triangle to see what it does to it. And once it does something to it, then you can understand exactly what it represents, rather than trying to swap them. Next, we go to the other part of the question, which says a transformation T is defined by the following 2 by 2 matrix. T is equal to 1, 2k, -1, and k is a constant, which is just a number. So that transformation maps the point 2, 3 onto 8, 15, and we're supposed to find the value of k. Now what we know is that once we multiply the matrix 1, 2, k, -1 by the point 2, 3, we're going to end up with 8, 15. So we're taking those coordinates and writing them in matrix form, and multiply the matrix by the point, and it gives us the image here. So we can multiply here. 1 times 2 gives us 2, and 2 times 3 gives us 6. That's 2 plus 6. And then here, k times 2 would give us 2k, and minus 1 times 3 gives us a -3. And that is the same as 8, 15. Now from here, you can see that 6 plus 2 is 8, which means that 2k minus 3 is 15. And so we can write that. We have a simple linear equation here, and we can just go ahead and solve it by saying 2k is equal to 15 plus 3. So 2k is equal to 18, and therefore k is 18 divided by 2, which is 9. So the value of k in that matrix is 9. Continuing with our question, we have part C. The following vectors are defined as shown below: wx, xy, and zy. All right, determine each of the following. So we want to find a vector other than 5, -1 that is parallel to wx. Now what does parallel mean? Parallel in vector ideas mean that the vector has the same component or is a multiple of. So wx is equal to 5, negative 1. So which other vector would be equal to 5, negative 1? We can take this vector and multiply it by 2. And multiply by any number. So for example, any vector k times 5, negative 1 is parallel to the vector wx. Any vector at all. So we could just simply multiply this by 2. So for example, we could say 2 times 5, negative 1, and that would give us 10, negative 2. Or if you wanted to use a different number, for example 3, k is any number that you want to use, and 5, negative 1, you would get in this case 15, negative 3, and these would be parallel to wx. Alright, so once you multiply by a constant there, any result that you get would be parallel to wx. Okay, moving on to the next part. We want to find wy. Now to get from w to y, we have to start at w. So one of these vectors need to start at w. Now interestingly, this is wx, so we can start there. So wx, wy, writing it out first, is equal to wx. Now pretend that you're flying, and you're flying from W to Y, where W is a country and Y is another country, or airport to airport. If you cannot fly directly from W to Y, then you need to take a connecting flight. And so we fly from W to X, which means that we need the flight that connects us from X to Y. And this is convenient in that it does that. So we could add XY to it. So wx plus wy plus xy gives us wy, in that we connect through x and we reach y. Wx is equal to 5, negative 1, and xy is equal to negative 3, 7. And we can just go ahead and add those. 5 plus negative 3, of course, is 2. And negative 1 plus 7 is 6. And so that would be the vector wy that we get by connecting these two vectors wx and xy. Continuing, we need to find xz. So xz, we are at x and we need to get to z. So xz, we could go xy, that is convenient, it's there already. So we go from x to y. Now we need something that connects us from y to z, since we want to be at z. Now this vector here has zy, and we want to work it as yz. That means we need to find the opposite of this vector and write it as yz. To write the vector in its opposite form, we simply just put a minus in front of it. So here we have xy, which is negative 3, 7, plus the negative of zy, which is 8, negative 7. And this comes out as negative 3, 7, minus 8, negative 7. Now negative 3 minus 8 here gives us a negative 11. And 7 minus negative 7 gives us 14. So the vector xz is equal to negative 11, 14. Then we are at the last part. We are asked to find the length of xy. Now when you see these two lines in vectors, what they mean is that you should find the length. And the length of the vector xy is given as the square root of x squared plus y squared, which is just Pythagoras' theorem. So we put in our numbers in there, x and y, which turns out to be negative 3 squared plus 7 squared, which gives us 9 plus 49, which is 58. Now normally I would leave my answer here because this is the most accurate form of the answer. This is not one of those square numbers that you can just write down a whole number value. So I would just leave it right here. Of course you could plug it in your calculator and write an approximation to a certain number of decimal places as you like. The question did not say what number of decimal places to write it, but normally just leave it here and that would be the end of it. So we have found the length of our vector, and it's the square root of 58. Well, since we're dealing with the length of it, we should actually write units, whatever the unit is. And that brings us to the end of our question and the end of our test. Thank you for watching. If you found this video useful, then please share it with somebody who needs some clarity on this kind of thing, and somebody who would probably just want to see the solution or get some insight and clarity on it. Thank you for watching, and until next time.